All right, all right, all right. The procrastination's over. It's either put up or shut up now. I've been working on this for quite some time, and I kept putting it off and putting it off. But the day's here now. This has been about a year or so idea of mine, and I finally got it started. But to be fair, I think if I would have started any time before now, it would have been too early, and I wouldn't have been ready. So without further ado, my name is Zack, and we're going to learn solid modeling and 3D printing. All right. So, uh, yeah, I'm Zack, and back in high school, back in '95 when I graduated, I learned while I was in classes. Let's see, they were industrial drawing classes, and I really liked that. And in those classes, I learned about AutoCAD, which was computer-aided drafting, and I bought a student copy from the college, and I taught myself AutoCAD Release 10 in high school, and then I went from there, and I went to college, and they taught me AutoCAD Release 13. From there, I went on an interview in '97, and I learned about SolidWorks '97, and I was really stoked about that. But I didn't get that job, unfortunately. Um, After that, I had a lot of different odd jobs and whatnot. Uh, Continuing to teach myself on the computer what I could about AutoCAD and different things. I had a program called uh, TurboCAD that I worked with a little bit. Uh, Somewhere around 2016, I learned about AutoCAD, or yeah, it's AutoCAD, Autodesk Fusion 360, which is the program we'll work with today. Uh, and I've been teaching myself Fusion 360 since uh, uh, 2016 or so. I think that's somewhere around when it was first uh, released. Anyhow, so that's Autodesk 13. I've also learned recently that SolidWorks has SolidWorks Maker, which you can use. It's $50 a year, and it's pretty much the full version of SolidWorks minus a few things. So that's really cool too. So uh, let's see. Uh, is the audio working and everything? I don't know if any of this is working. I hope it is. All right. Uh, I see I have one viewer. Thank you for viewing. All right. So we're going to move on to what we're going to talk about here. I have a small project we're going to do for this first stream. Uh, it's something I just made for a product I have. I guess I'll open up my auxiliary camera and show that to you so I can show what we're going to look at here. Let me get that started. Okay, there we go. So this is what we're looking at. This is something here that I have. There we go. All right, this is something here that I have 3D printed and designed. This is a USB port that I have. It's stuck to my desk. I recently 3D printed this. It's just a little cover for that SD card thing that I made. It's not really practical, but it was fun to do. So I see I have viewers. If you could let me know in the chat if you could hear me. I have no idea if my audio is working. And can you hear the background music? Is it too loud? All right, so we are going to work on this. I'll pull it out of here for you. This is what I got. we're going to 3D print this, or we're going to design this, and we're going to work on the 3D printing next week. I didn't have cameras and stuff for my 3D printer. So, okay. I guess, let's see. It's time to step into Fusion, I think. Let's get rid of the camera here. Oh, come on. There we go. Okay, nobody's let me know in the chat if you can hear my audio. So, all right, we're going to step into Fusion and start working, I think. I'm not sure, can't remember. Oh, the second part of the show, excuse me, the second part of the show, I plan on, I don't think I'm going to be able to get into SolidWorks. There seems to be an update I didn't know about, so I'm going to have to do all that later. So I'm also on Fusion. We're going to work with, there's a website called tuteltoby.com, and he has a esports for CAD drafting. He has a competition that he does where he puts drafter against drafter, and they see how fast they can do models. And so we're going to do a practice model on his website for the second part of my show here. So okay, so they can hear me but no background music. That's cool. I couldn't figure out how to get the background music working, so that is what it is. Thank you. All right, so yeah, so that was the second part of the show. And then yeah, for next week, we're going to introduce the 3D printing, and in the third week, we're going to talk about the item that's behind me in my background. That's something I modeled up in Fusion and SolidWorks also, actually. And then I 3D printed, and it's a product I use in my kitchen. So we'll talk about that. That's something we'll get to in the third show. So let me, I need to find something real quick and get it open. Let me, where is that? Hold on, give me just a second. Where's that at? Everything's open and I can't find it. Hold on. Where's it at? Where's it at? Give me just a second. Oh, there it is. I did have it open. Okay. Okay, now that's working. Now let's open everything else back up again. And I want this open up here. Let's see where we're at. There we go. Okay, everything's open. We're going to close this. All right. Now everything's working. All right, we're going to get to the meat of the show. There's a couple audio tracks I couldn't get fixed also from the start of my show and for where it would be right now, but that's okay. We'll get that fixed for future shows. All right, so I'm gonna click on to the next part and we'll get started, I think. Here we go. Okay. This is Fusion 360. This is where you make solid models of drawings, so you can manufacture them in different ways. At a CNC shop, you can machine them in lathes or mills, and you can send them to plastic shops to get them molded and different things. I use it currently to be able to 3D print things. But anyhow, we are going to get started. Okay, so I guess the first thing we do when we start a drawing is we want to see, I'm trying to figure out if I need to open up the one that I've already got done here. There we go. Let's open up this. Okay, this is the one I've already got modeled. This is what we are going to, this is what we are going to view. And I may have a problem. Shoot. Okay, I'm going to not worry about that today. Okay, all right. But we're going to model it from scratch. So we will proceed to do that. Yeah, all right. Here we go. We're going to a new design. All right. And we're going to, so my 3D printer is all metric. And if you try to convert everything into standard or inches, it really affects things when you try to print it out and you have to make adjustments. And to avoid all of that, I just draw in millimeters. So the first thing we're going to do here is oh, hey Mom, how's it going? Thanks for watching and chatting. Don't forget to like and subscribe. Anyhow, let's see. First thing we got to do is set the units to millimeter. So yeah, we will do that. Let me get in the right. Let me do it. Okay. Yep. Nope. Maybe. There it goes. Okay. We got to click on that icon there, and then we can come in here and click into. We want to switch to millimeters, and I could set it as my default because this seems to be what I work in most of the time now. But I'm American and I like keeping it my default as standard, and so I just switch it if I'm gonna draw in millimeters. Anyhow, okay. Oh wait, cancel this. Okay, all right. So, all right now, next thing you want to do is we want to create a component so we can I guess I can't explain the reason for this. It's just common practice. It makes it a lot easier to work with when you're in assemblies and multiple part drawings. But we will name this component, and we're going to call this a USB USB cover. Okay, and that will give us a new component over here, and it will also make that component current. So that's our current component we're working in. So any adjustments we make will be made to this component. When you're working in one single drawing, it doesn't matter, but when you have multiple parts, you'll want to make sure that you're working in that component when you're making adjustments for that component. It just keeps things organized for future use, whether you have to make edits in the future or whether you do whatever updates or whatever you have to do in the future. This all helps us keep organized so those updates are easy, basically. So, all right. So from here, we're gonna also save this, and we're just gonna save it as the same name that we named the component. So we'll call it the SD reader. All right. Oh, what did we do? The cover SD reader? Yeah. Cover SD reader. Okay. All right. And save. All right. That'll get us there. And then from here, next thing we want to do is we have to create a sketch. This item is a specific size, and we need to make a sketch that accounts for those sizes so we can extrude an item to start making a solid model. So we have to know some things about our product that we're going to make a model around. So we'll make some measurements. What we're going to do is make some measurements. So I have a Metatuyo caliper. It's a machine shop grade caliper. For 3D printing, you don't really need a machine shop grade caliper. You can go to like Harbor Freights and buy their cheap calipers and use that. I just happen to have been a previous machinist, so I have really good calipers on hand. But we have to make some measurements. So we will measure the item here, and we'll measure the item here, and we'll write that down, and then we'll make a sketch based on these drawings that we're getting right here. So our first measurement shows it's about 7 meters wide, or 7 millimeters, excuse me. So we'll write that down, 7 millimeters. All right, and then we'll measure our width here, and it comes up as 15. We'll say we're 16. Yeah, we'll round that up to 16. It says 15.97, but for our purposes on our 3D printer, we can round that up to 16 because the 3D printer is the extruder on it is 0.4 millimeters, and the layers it prints at are 0.2 millimeters. And by the time you have expansion and compression because of heat and cold, after it cools down, because it was hot when it was printed and it cools down, things cool and expand. So the dimensions are slightly different than what it's going for. So basically you could round up to the nearest 0.2 really. So we will measure that as 16 millimeters, and now we will make a sketch based on that information. All right, this is really weird. My preview is about 20 seconds behind me, so that's a little confusing, but I will continue to move on. All right, so up here we have our toolbar. Oh, excuse me, I have to transition back. Excuse me. Yes, transition back. All right, I'm back. Okay, so this up here is our toolbar. for beginners, it's a great place to find your tools. There is also a shortcut that you can set up on your own, and from there, it's simply just typing the S key, and you can set this up. Hold on, I am not sure what's going on. That is not supposed to be there. Okay, hopefully. Okay, there, I don't know what mistake happened there, but that shouldn't have happened. I didn't click on that. Sorry. Okay, I'm back. Okay, so this is your toolbar, and you just have to click. Oh, I think I know what happened. Let's make sure. Okay, I see what happened. That was my mistake. Okay, so this is our toolbar up here, and our shortcut toolbar comes up if we hit the S key. Oh boy, it's gonna happen again. No. Okay. Okay, it's back. I'm not sure what is going on there. So this is a shortcut key. This you can set up. To set this up, you can put any key up on the shortcut key. To be able to do that, you just have to, when you're in the toolbar and you go into your toolbar key, you can click on this icon next to your key tool that you want to click on, and from here you can pin that to your shortcuts. And as you can see, I already have this pinned to my shortcuts. And if you want it on your toolbar, you can also pin it to your toolbar, and you can make changes by clicking here. But it's simple as that, real easy. And even Solidworks has that awesome shortcut toolbar just by hitting your S key. And there must be a shortcut in my OBS for that, because OBS keeps reacting to the S key. So I'll have to make sure that gets fixed. But in our S key, we want to sketch. So I will click on my sketch key and we will start that sketch. Now, the first thing the sketch asks us is what plane do you want to sketch on? And it really doesn't matter, but sometimes it does. For machining, when you're designing for machining, you want to know your X, Y, and Z, because you want it specifically on your machine plate when you're doing machining. And even your build plate, if you put it on your right plate, it'll load into your slicer, so it's on the proper surface when you load it in. But in the slicer, it's so easy just to choose what surface you would like to start on your build plate, that it doesn't matter. But I'm gonna start on the top surface plane here just by clicking on this plane, and then that'll bring us to the sketch view here in Fusion, and from there we start our sketch. And okay, all right. Okay, from here we move on to what we want to sketch first. And because we're sketching a rectangle, we can start with a rectangle. You could start with lines and draw 4 lines, but we're drawing a rectangle, so it's really as simple as drawing a rectangle. And I do have rectangle on my toolbar, but my shortcut bar is set up, so I will simply use my shortcut bar. And there are different kinds of rectangles we can draw, from a 2-point rectangle to a 3-point rectangle. There's a center point rectangle, and for our purposes, let's see, I don't want, let's see, where do I want my center point? I don't want the center point at the center of my origin point. I think I want my origin point on the corner of my drawing. So I will choose a 2-point rectangle. And from a 2-point rectangle, we will start right from our origin here. This is our origin. This grounds everything to 0, 0, 0 in your XYZ coordinate point for Fusion. It just helps Fusion keep itself organized. So we will click on that and start our rectangle. It's too bad the audio won't come through, but that's okay. We'll get that fixed for the next stream. Okay, to use the rectangle tool, it asks us, well, 2 questions mainly, but you can answer others, I believe, also. Anyhow, so for the first question, we want to answer our width. And we know that we wrote down a width of 16 millimeters, if we remember right. So now we can just type this in, or we can just click here and leave a box at just a blank dimension, and then we can click on the dimension tool and dimension it afterwards, or you can dimension right here in the tool. I think this time I'm going to dimension right here in the tool. So in the red toolbox that's highlighted there, it shows 75 point whatever millimeters you see now. I will type in that the 16 millimeters that we measured and get that. And I will not hit enter, I will hit tab, and that brings us to the other dialog box with the 52 millimeters in it. For that, we want to type in our thickness, and if you remember our thickness, we measured 7 millimeters. So we will type in the 7 millimeters, and it will get that for us. And there is nothing else we want to tell this drawing. And I was thinking we could get some angle information too, but I don't think the toolbar lets us choose that at this point. We do that if we needed to do that. We could do that at a different time. So right now we will hit the enter bar, and that will place our rectangle that we just drew. And I will zoom into this, and I will click on this dimension and scroll it up, just because I like to tighten things up. Just cleans things up. It's not necessary, but I'm kind of anal, and I like things to be tightened up. So here is our drawing, our sketch, and we have a rectangle that is 16 by 7 millimeters, and we have some information here. If you can see these little icons that are here and here, that is just telling Fusion that those lines are at a horizontal and vertical to the origin. That tells, yes, Fusion that everything is at 0 and 0 degrees for, or well, 0 and 90 degrees for those angles. And it defines the drawing and makes them black. If I were to delete these, wait, that's not. If I were to delete those, let's see. Yeah, delete those and delete this one. See how it turns these green? They are undefined. That means I could change something about that line. There's something that I can change about it. Something Fusion doesn't know about it. I could either make this equal to this one because this one is still defined as horizontal, and that will define it, or I can just redefine it as horizontal, and I will just redefine it as horizontal like it started. And I will explain more about that kind of stuff as it becomes more pertinent to what we're doing. Basically, you want drawings to be defined. It helps with making future edits and doing different things in Fusion. What you call parametric drawing. It just keeps it future-proof. So there's nothing else I think we need to know about this sketch. Every other thing we're going to do, we can do in, no, you know what? I take that back. I think we're going to go ahead and offset this in the sketch and make the full item. Yeah, that's the way I want to do this. So we're going to make an offset. So we'll click on the S again and bring up that shortcut key, and we're going to make an offset. So we will click on the offset key. And one thing I didn't mention is the shortcut key is different based on what mode you're in. And because we're in a sketch key now, that shortcut key comes up with sketch mode buttons. If we were in the modeling or the modeling mode, and we were like extruding and stuff, then we would have a completely different shortcut key. So just to bring that to everybody's attention. Okay, so we will create this offset. So this offset dialog box asks us what curves we want to offset. And by curves, it means which lines we want. And it also asks if we want to change selection. If I were to unselect this box, it would then just select one line at a time. You can see where they are highlighting in blue for me. But I want to do the whole thing. So we want to chain the selection, and that will select the whole rectangle for us. So we will select the whole rectangle just like that. And then we only want to go one side. We don't want to do two sides. If we were to click two sides, it would offset both ways. And for our purposes here, just one side for us. So we will unselect that box. And then the flip rotation, this goes inside or outside, and the dimensions we did on our rectangle are the inside of the product we are going to extrude here that we're working on modeling. So we want to offset to the outside. So we do not want to flip sides, so we'll stay on the outside. So we will go into the distance. So in the distance, we want to tell it how thick of a wall we want to extrude this. And it really doesn't matter. It's just based on how thick you want it. And I think I went based on my extruder. My extruder extrudes 0.4, let's see, yeah, 0.4 millimeters at a time. So everything is 0.4 millimeters wide to begin with. So when you're printing things, you want to design based on that 0.4 millimeters, because you really can't print anything with a higher resolution than that. So there's no reason in designing anything with a better resolution than that. Okay, I bet I could add audio, but it would take me a second. I keep thinking about it. Okay. Okay, I forgot where I'm at now. Okay, so how thick are we going to make this? Yes, our extruder is 0.4. So, and it prints 2 walls for your outside wall. And your walls are then 0.4 millimeters thick then, because that's what your extruder can print. And you can, with 3D printers, I can put in smaller nozzle and print smaller extruder points. But I have found that I have had issues, so I have printed at 0.4 millimeters right now. Until I learn more about my printer, I will continue to do that for now. So we have to decide how thick we want it. So our inside wall is going to be 2 walls thick. Our outside wall is going to be 2 walls thick. So that's 0.4, 0.4, 0.4, and 0.4. And then how much distance do you want? How thick do you want in between that? How much infill do we want? So we're already at 0.4 times 4. Let's see, what is that? 1.2, 2.4? Is that right? 0.4, 0.4, 1.2, no, that's 1.24. Now I'm lost. 0.4 and 0.4 is 0.8. And 0.4 more is 1.2. And 0.4 more is 1.6. All right, so that's 1.6. And for the one I've already printed, I did that one at 2.6. So I must have done yeah, I'm so slow at math. I'm gonna pick up a calculator and get this done, or I'll be sitting here all day. Thank you for continuing to watch. Let's see. We're at 2.4, and I'm subtracting the 1.6 that the walls are. That means we're doing a 0.8 infill. Anyhow, now that that confusion is over, the distance we are offsetting here is 2.4. 2.4. All right, and we will okay. So we will okay that, and that finishes that offset, and you will see that we now have another rectangle that is 2.4 millimeters bigger than the one that we did before. And now there is other things we could do with this sketch as far as chamfering and filleting the corners. but I've been taught best case scenario, keep it simple, stupid, and keep your sketches as simple as possible and do all your edits as a solid model. So we will do chamfers and fillets as model modifications instead of sketch modifications. So we will call this sketch finished and click on finish sketched. Okay, that finishes our sketch, and because our sketch is black, that means it is fully defined. And if you're not designing for a company that wants you to design their product for, legit companies, knowing if your sketch is defined or not really doesn't matter. But it is best case scenario, and I'm kind of anal, so I like to do things the way that they do in the industry. It's the way I'd like to teach. Again, they don't have to be well defined, and we will discuss the reasons for that in the future, but I will move on. The next thing we need to do is extrude this. There's a few ways we can do it. We could go up to our toolbar here and click on extrude. Since I haven't used the toolbar, I will click on the toolbar this time. There is my shortcut key that has the extrude there, or I could click on the profile. You could see there's this profile, there's this profile. I could shift and select both profiles. I could select that profile and hit E for extrude, and it'd go right in the extrude function and start extruding by doing that. So there's multiple ways to get into it. For this demonstration, I will use the toolbar this time. So we will click on extrude, and that brings us into the extrude mode. Okay, to extrude, they want to know a few things. They want to know the profile. We already have that selected because we had that selected before we selected on it. If we didn't have anything selected, this wouldn't have been highlighted. Or, well, it's still been highlighted, but it would have had 0 selected, and it would have asked us to select something. But it has 1 selected, so, and we do know that's what it is, and that's what we want. We only want to extrude in one direction. If we click on the down arrow, it gives us other choices as far as one side, 2 sides, or symmetric. Those options are one side, it's just extruding in either the direction, in one direction, either, well, in our case, we're either going to go Z minus or Z positive, whatever distance we give it. You could select symmetric, and then you could give it a distance, and it would go both ways from your profile point or your profile line, your origin line. I'm messing this up, but your profile plane, I believe that's it. Your profile plane, it'll be symmetrical, extrude symmetrically the distance, whatever distance you give it. So, and then 2 sides, you can give it different distances in the Z minus and the Z positive. But in our case, we only want one side, and Now we can pick the distance, and we can pick a distance from somewhere else, or we can pick a distance from a different object. Or no, this is the distance too. I'm sorry. Yeah, okay, so yeah, the profile plane. Okay, so let's start over. So we selected our profile plane, which is this. We want to start from our profile plane. We don't want to start at an offset. If we selected offset, we could choose an offset from that plane. If we, for some reason, we wanted to start our extrusion from a different offset, and there are reasons why you want to do that, but we don't have anything else to offset from currently. Same way with object. So we can't select these two. I mean, we could select these two, but we don't need those two, and there's nothing in our case right now for those. So we're just going to extrude from the profile plane. Our next decision is the direction. Which direction do we want to extrude? We only want to extrude one direction. Before, I explained two directions or symmetrically. Our choice is one direction. Our distance, we could decide to go from an object or to an object or to all objects. Right now, we don't have any other object to choose these, so we are going to select distance, and then in the distance dialog or the distance question, we are going to answer how tall we wanted to measure that. And I measured the item, and it's 23 millimeters, but the item on the back of this item drops a little bit lower, so we can't extrude that whole distance. So I only extruded a distance of 20 millimeters because that's how tall this product is that we're going to be designing this little thing we're going to be 3D printing. Okay, so that's our next answer, and we don't have a taper angle in this design. The reason they ask for a taper angle is in industry, when you're designing for a mold product, they design those molds with a taper angle, so when the extruded product or the injected product is separated from that mold, then when it's being manufactured at the factory, has to separate. The plastic has to separate from the mold, and if things were straight up, they don't separate so easily. So they've learned to design things with the taper angle so they separate easily in manufacturing. And we don't do that for our 3D printing, so we have a 0-degree taper angle. And this is a new body for us. We don't have any other body to join to or cut from or intersect to, and we're not making a new component. We already have designed, or we have already created a component, so we are creating a new body. So we now collect OK, and that extrudes. So we will now rotate, and we can see a extruded solid now. Okay, with our extruded solid, we will make, wow, I've been going for an hour. I thought I'd been done with this 20 minutes ago. Let's see. Hello, new viewer. I'm not sure how to find out who viewers are, but thank you for tuning in. Sometime I will find out. I know I can find out who viewers are, but I haven't figured that out yet. But anyhow, welcome. Okay, so we are extruding here. We have extruded a solid, and from this solid, we have to know what we want to do next. And because I didn't get my 3D mouse turned on correctly, I cannot orbit correctly on screen. So I have to remember how to do it manually, and that is the problem I have. Anyhow, this is orbiting. You have to click Shift and the middle mouse key and scroll your mouse around, or move your mouse, not scroll, and it orbits your solid model. Okay. Zooming in and out is done via the scroll key on your mouse. To pan, you click on your scroll key and roll your mouse key either left or right or up and down, wherever you want on your screen, and that is your pan. And you can do, well, when you're in sketch mode, you can only pan in order to do any orientation of your origin point. You have to click and do specific things. So they make it easy for you, because when you're sketching, you don't want to be orbiting, because you want to stay square to the face you're sketching with. Anyhow, all right, so the next thing we want to do, that is the meat of the shape of this thing. There's nothing we really got to add to it. So I do have a text item that I added to the front, only to add decoration. No other reason. It doesn't have to have decoration, and you could really do anything for decoration you want. And for this demonstration, we will do the sketch demonstration to demonstrate how to easily model, extrude, model, and do a sketch component. It's not too hard. So the next thing we got to do is create a new sketch. So we will click our S button for the shortcut key and click on the sketch icon to create a sketch. And we click on that, and again, it asks us where we want to start our sketch. And this time, we don't want to go to one of these zero face planes from the origin. We want to sketch on a face. And I can sketch from any of these planes or profiles. You can see they highlight. And if I wanted to actually sketch on the profile on the bottom, I could click on this face here and hold as I click, and it'll come up with this dialog box, and I could choose other faces, and you could see what highlights the faces to choose, and I got either this face or that face. And of course, from this decision, I just want this face. So, oh, oops, we're going to cancel that. I accidentally clicked on it. We want to cancel. We will restart that. Sorry. We will start our sketch. Okay. I want to create that sketch on this face. So that is the one we are going to choose. And it again rotates us automatically to the sketch plane. Now in settings, you could make that so you could offset that so it doesn't automatically go to the sketch pane. But for most cases, oh, I see what's going on. Okay, for most cases, you do not want, I forgot what I was talking about. Oh, for most cases, you want to go right to your sketch plane. In very few cases do you want to sketch in a plane other than to sketch out here would be very difficult because you're sketching in a 3D plane and you're sketching a 2D object. It's very difficult. Oh, I did it again. Let me cancel. Let's continue this. I'm sorry, I'm making mistakes here. Okay, let's start. Cancel. Let's start. Okay, cancel. We are going to restart this sketch. Where are we at? What's going on? Come on. Restart the sketch. Create sketch. Okay, it asks us which plane, and we want to sketch on this front. Okay, so we are on the current plane, and it has orientated to that automatically for us. And we want, yes. So on the sketch plane, we want to start a sketch, and they will not allow you to put, what they do? They will, okay. They allow you to put text on your shortcut bar, but I don't necessarily want it on there. So I click on the key from the toolbar, click on the text, and to start your text, it wants to know where on a drawing do you want to start your text. We want to center on everything. So to do that easily, we want to select from our corner points, and you can see how this is snapping to our corner point there. It highlights the square. It turns from the plus icon on your cursor to the green. Well, when I click on the line, it goes to the X and the green X, and that means it's snapped to that line, but we want to snap to the corner. So we want to go like that. You see how it turns to that X on your cursor, and it's green. That means that the corner is your snap to that corner, and that is what we want. So we will left click that, and we select that, and then we will drag down. If you'll excuse me, I have to take a drink. I am getting a little bit parched, so give me a second here. I'm going to take a break. All right, still got 3 viewers. That's awesome. Okay, thank you for watching. Let's see. Don't be afraid to chat with everybody. That does help the analytics. What is that? Subscribe and like, please. Okay, so for the next thing we need to do, we need to snap to this other corner, and you can see if that it has highlighted and green turned to a little square for us. So we click on that corner, and that shows us that everything is snapped to those corners, or snapped to that face for us. And that's what we want. And it comes up with sample text, and we will type right away what we want in our text dialog box here. These dialog boxes we can move and make snap anywhere on our screen for us, but for the most part, I like the default position for them. You're allowed to snap them up here and things, but you have to, I find that you have to change that every time you relog on to Fusion. So I just leave them in the default spot so I don't have to change that every time. So yes, so in our dialog box, we choose things. The first thing it wants to choose is a type. The type is just general text or text to a path. And in our project, first of all, we don't have a path to select, and we don't want to do that in this project. So we're going to select just general text. I will explain to a path in another project, but basically, let's say if we had a round object or something that we wanted to attach text to, and we had a path that was some sort of Bezier curve or something similar, we could select that and it would snap to those things. For us, we just want a rectangular frame. So we select the default, or just leave the default the way it is. In the text box, this is where you text any text you want. In our case, we can text any text we want, any phrase, anything you want. We don't have a lot of room, so we just want one letter. And in our instance, we are just going to choose Z. We could choose anything we wanted. Our font, in here, you can choose anything that your computer has access to in the font library, but Fusion can only, when you go to extrude things, you have to explode the text, and I'll explain that in a few moments. And if you wanted to do different text, Fusion doesn't have the files in some of these text files to, it doesn't have the data that it needs to do the explosion. When you do the explosion, it doesn't have the data that it needs. So you have to do, you only can select certain font files. And I stay with the default Arial because it is the easiest one and Fusion can communicate with it easily. So I will stay with Arial in this demonstration because I haven't had time to discover which fonts are compatible yet. So I stick with Arial, and we want to boldface it so it makes it bigger. And we will stay 10 millimeters in this demonstration for height because that's about what we're going to work with. Alignment, we want this centered, and centered, you could choose your alignment. This is your justification, right or left or center. Just if you were writing a paragraph in your word processing program, you've got a left or right justify. In our project, we want to center. That gives us everything centered the way we want it, and it centers it right up. Okay, and here we'll mess with the height just so you could see that 10 is about where we want. You know, if we did much more, you could see we could get, oh wait, that 201. But anyhow, we'll stay with 10. So we'll select OK, and that places the text for us. And that's all we need for the text. If you needed to edit that for any reason, you could come down here onto the history toolbar. There's a name for it, and I can't think of it right now. Yeah, so that I'll call it a toolbar. When I come up with the name, I will let you know what that is. This down here is your history of what you've done as you've modeled things. So here you can see this is the sketch that we are currently in. And you could name these things, and it is actually best process to name these things, but we don't work for a company, so it's not that important to us to do these types of things. If you were working for a boss and he wanted that thing done, then you would have to do those things. But for 3D printing and home use, that is not that important to us. But it does help keep things organized. And if you are working for multiple things and you're planning on making multiple edits to things, you would want to go ahead and make changes to the names of things. That way you could remember you would name them what you did, and that way if you had to make edits, you could remember you name them what you did, and in that way you could come back to it, and you could come back here and make edits. And it keeps you organized, so you know what you have to come back to make edits. So anyhow, your tool history bar, you can see here is our edit. Here is the extrude that we made, and this is when we started and we made the component, when we first made the component. So we want to edit the sketch, so we will left click instead of right clicking. We will left click on that icon, and then it gives us this box, and at the top it has create. Wait a minute, does it not? Oh, we're already in the edit. Oh, okay, we're still currently in the edit, so we can't edit the edit or edit the sketch we're already in. So we will go away from that. We will select then on the text here. What we want to do is left click. We will left click on the text, and that gives us this box. I'm sorry, I forgot what we were doing. From this box, it gives us options, and we want to scroll down to this explode text. We want to explode the text, and that separates it. It makes it not text, and now we can no longer edit the text. It is no longer editable, so we will not be able to right click on this and go down to click on edit text anymore. We can only do more text. If we wanted to edit it now, we would have to delete it and add more text. So now we are finished with this sketch, and we click finished sketch, finish sketch, sorry. and we finish that sketch, and we have this. I don't find it too important to fully define text, so I don't worry about that kind of thing. So we finish the text. Okay, now we can do this. Where are we going? Oh, wrong button. Wrong button. Sorry. All right, let's do this. So now we want to extrude that profile. We will click on that profile, and we will click E for extrude and get the extrude tool. Okay, we are going to relax a minute. Okay, next thing is extruding. Wow. Adrenaline just went weird. Okay, so we are going to extrude, and in our questions in the dialog box, we want to go to the profile plane. I could choose other planes now, but we already designed a sketch on the plane we started, so we will extrude from that plane. We're only going to go in one direction, and we're going to do a distance of, let's see, our wall thickness when we print is 0.8 millimeters. So you want to extrude at least 0.8, and you want a little bit of infill. So let's see. I think we're going to extrude 1.4 millimeters, and that'll give us a wall thickness of three walls. Yeah, 1.4 millimeters. Okay, so that's how far we're going to go. We will click on OK, and now you will see that we have extruded that, and we have a Z now on that base, and we can zoom and orientate our drawing. I wish I had my way because it orientates more precisely, but something like this. Okay, all right, we have this. All right, next thing is we need to do some printing up of this model. We want to fill it in chamfer. Let's do the chamfer first. We will chamfer our inside profiles just for neatness. There is no other reason than that. And it is kind of best practice. We could print a square there, but it kind of looks ugly. And best practice is to clean this up a little bit. So we will click our S button for our shortcut button, and I will click on my chamfer button. We'll go into the chamfer mode. The first thing we want to know is which edge of chamfers we want to click onto. The first, we only want to do this bottom profile. We will select those. If they were connected by a chamfer or a fillet, it would be a tangent chain and select all of it. But because it's not a tangent chain in this case, that's not possible. But we will select this, And in this mode, you do not have to collect, or I'm sorry, you do not have to hold shift to select multiple things. It will do it for you in this mode. Now, if I did select something that I didn't want, I would have to hold Control and select to unhighlight, just like that. So we've selected the 4 edges that we want, and now we want to know what distance we want to do that. And there should be, oh, here it is. This dialog box pops up, and as you can see, it's already highlighted with the pink or reddish that you could see there. But and I could just start typing with my keyboard and it would go right into that dialog box. But I like to confirm that it's going to go there. So most times I select in here. And in our purposes, we only want to do equal distance. We could choose 2 distances or distance and angle. And for our purposes, we're just going to do equal, and we can discuss other options when we use those different features. So we're going to do a chamfer of 1 millimeter. Remember, we only, this item, this wall, is only 2.4 millimeters thick. So we don't have a lot of room, but we only need to chamfer 1 millimeter. So that is the distance that we are going to chamfer, and it chamfers up each wall 1 millimeter, up this wall and up this wall 1 millimeter each. So it has that 45 degree chamfer. So that's what we want. We could choose these other chamfer types, and 99 times out of 10, you will choose a normal chamfer. I do not know of any reason why you would choose these other items. I'm sure somebody might know the differences. I do not. So we have answered all of the questions we want. So we will click OK. I think I could also hit enter right here, and that would also tell us that we were done with this tool. So we'll click OK with the left click. It finishes, and it has created the chamfer. You can see it has done that for us. And we have a nice clean chamfer. And I will look at my model. What have I done with it? And I will see. I don't know if I did that. We are going to go and look at the other one I created. This is the old one I created. And we're going to look at it and find out what I did to this model. Oh, geez Louise, I'm having connection issues. Yes, there we go. Okay, we will go into this model and see what I did to that model to beautify it real quick by going in here, left clicking on this. Now you can go into edit feature, and it will tell me, yes, that we just did 1 millimeter, and we did, oh, it looks like we did, oh, okay. That's those 4. That's Okay, now I'm on the same page. Okay, so we did our chamfer. I just want it down there. I don't want to chamfer the top. The biggest reason for chamfer on the bottom is because I want bottom to be really nice for the 3D printer. When the 3D printer prints, it prints a little bit of over extrusion, and if you have a nice chamfer, your over extrusion is a little less and a little nicer. So we have just the one chamfer on the bottom, and now we want to do another fillet. So we will hit the S button, go into the fillet mode, the fillet tool, the S button, and go into the fillet tool. Yes, there we go. Okay, and we'll create a fillet. Now, I want to create a fillet on these corners. Excuse me, and these corners, and these outside corners. And I also want to do this top, but and you could do them in the same step here, but I like to separate them for this easy model, so we're just going to do it once. But normally you would click here and you could add different selection. Well, let's see, when you first start, it's on it automatically and you don't have to add. But if you wanted to add more, after you did your first one, you could add more. And I'll explain that here in a second. We were going to, okay, so it's asking me to select edges or faces. We're going to select, or no, let's see, clear, sorry. These edges are the ones that we want to select. Now I could orientate around and find these corners to select, but if you, as you see, it will highlight the corners even if you are hovering over solid profiles. So you can see it's selecting my edge here. I will select that edge through that, and it selects it for me. Now I want to select this one and this one. I also want these inside corners selected, so I'll select this one. If I can get close enough, I'll select that one and this one. Okay, those are what we're filleting. And fillet just means a nice little pretty round edge. And the reason for doing this is to make it a little less sharp, so this will slide through there a little easier, the part we're manufacturing around. Okay. And our extruder on our 3D printer is 0.4 millimeters. So your resolution is only 0.4. So you don't want to do anything smaller than 0.4 millimeters. So I think I did a resolution of, or a fillet of 1.6 millimeters. Okay. Okay. So in our model, oh shoot. All right, let's select those edges again. Yep, we're out of it because I changed. Sorry, folks. I am unprepared. Oh, Okay, yep. Okay, we got all eight again. Okay, so how round do we want to make this? Our extruder is 0.4, and I went 1.6. I don't know why I did that big. I'm not going to do that again. Okay, so let's go 1.6. We'll enter that in. That's how big that is. And we'll click on OK. For some reason, I think that's wrong. Let's check this again. Sorry. That one. That is wrong. That's why. That's what's going on. Okay. I see what I did wrong. Okay, I did the other one different. Okay, I don't recall what I did. Oh, okay, I do. Oh, okay. All right. Okay, gotcha. Okay, so we're gonna go back and we're gonna go in and we're gonna edit our profile, edit feature. Okay, so I did this different. I did the outside radius is different than the outside radius. So we are gonna go in and we are gonna edit this. We're gonna select these edited and we're going to add. And this allows us to edit these. So we are going to deselect by holding Control and selecting our interior corners. Sorry, everybody, this is going to take me forever. I did not want this to be a 2-hour stream. Okay. This is the only thing we're going to do here. We're not going to get to the other item that I wanted to do on tuteltoby.com. So we will not change that. All right, I got 3 viewers again. Thanks for viewing. Okay, we are back to our 4 corners. We just want those 4 corners, and those 4 corners we are going to go at 0.8 millimeters, and that 0.8 is 2 times 2 of our extrusion. Our extruder is only 0.4, so we're going to do this one 0.4 or 0.8, so then it's double our extrusion on the outside radius. The inside radius then we're going to make different, so we will push on the add here, and this will allow us to add a new set of features, and we will add then these 4 corners so we can fillet those. Now we have those 4 edges, and these then we are only going to do 0.4 millimeters, and that is 1 time distance of our extruder. And the reason for that is we want it to be filleted in the middle or in the inside just enough so it's nice for our extruder, and our manufactured part that we're designing for, and our 3D part will marry together easily, and we can slide the manufactured part into the 3D printed part. So we will, that's why the interior fillet and the outerior fillet is to make it nice, just to make it look nice. We don't want it square, we want it nice and rounded. Okay, so we are done with the fillet on here. We will click OK. So we have filleted we have chamfered the bottom, filleted the outside and the inside, and this top edge here I want to fillet again. So we will go back into the fillet tool, which is also up on your toolbar if you want to use that versus my shortcut key that I typically use. Anyhow, in the fillet tool, again, we will click the top tangent chain, and it'll select that whole thing for us, the 8 edges, and we are going to fillet 1.6 millimeters, and that's just a nice round number for our extrusion. Our extrusion goes into that 4 times. Okay. We will finish that. And folks, I think we have a nice finished part here. I think that's what we want. There is nothing other than that. I don't think we need to do anything else. We're going to discuss 3D printing in episode 2 when I can get cameras and lighting ready for my 3D printer. And in chapter 3, we are going to get to that product that I have started working on designing from the base products to the 3D product. So, without further ado, I think we're finished here. There is nothing else that I want to do with that part. Why is that taking forever? I hope we're still... Oh, wrong thing. This way. No, back again. Okay, we should be on this new screen now. Okay, sorry. Okay, on this screen, I think that's the end of the show. That is the 3D model part. I was going to go to the Too Tall Toby website and show you some sample work, but it has taken way too long for this stream. We are about an hour and 35 minutes in, and I thank the viewers so much that have chosen to tune in and view. Thank you very much. We will discuss getting into Cura. That is the slicer. That is how we 3D print in the next episode. Okay, sorry for the dead air. Sorry for the dead air. Okay, I think that should be the end of the show. I think we're back. Okay, I think it's working. Okay, where are my notes? Tell me my thing. Okay, there it is. No, that is not it. Oh, I found it. My thing. Okay, my little secret sketch for my closing remarks. Okay. Folks, thank you for tuning in and using your evening to choose me as entertainment. So, thank you for sticking through my learning my learning curves and whatnot. we are going to call it a night. Thank you for feeling. Sorry, starting to get emotional. Uh, okay, deep breath. Okay, let's see. Rock on, hang loose, and peace out. We will see you in the next show. Thank you.